Hello, everybody. My name is Michael Gutmann. I'm faculty in machine learning here at the School of Informatics, and I'm talking to you in my role as a program director for the AI in MSc program. My background is in engineering, so it's not in AI. So like many of you, I haven't studied AI in my undergrad or in my MSc even. I had to study a lot, like many of you, in my undergrad and MSc. So I became interested in learning, and hence I embarked on a PhD in better understanding how the brain does the learning. So I did my PhD in computational neuroscience. And then only actually during my postdoc years, I got into machine learning because we wanted to solve a practical problem in computational neuroscience, and we used then machine learning methods for that. And then I became interested in doing research in machine learning. And now my research are in machine learning for science, so how to apply machine learning to problems in the natural sciences, something called Bayesian methods, which is about reasoning under uncertainty and how to take decisions when there is uncertainty. And I also have a strong interest in self-supervised learning. So you see, I have quite an interdisciplinary background, and this is quite characteristic of our faculty, actually, and our type of research and teaching that we are doing at the School of Informatics. So why study AI in Edinburgh? First of all, Edinburgh is a very pretty city. In any case, please come and visit. This street here is the Victoria Street. It's really picturesque, and it also has a lot of good restaurants. So yes, the food in Scotland, or in Edinburgh at least, is very good actually. So why study AI in Edinburgh? Well, the main reason really is that we are really good at what we are doing. We are also one of the largest schools in the world with more than 160 academics, and we thus cover practically all angles of AI and machine learning. I'm here just showing some examples. Here on the left, we have an example of how to use machine learning to make AI agents safer. So the red blocks here for some competing methods means these are blocks where the AI agent would be bumping into, while a method proposed by researchers in our school avoid these obstacles successfully. There is also a large work on natural language processing that is being done in our school. So here I have an example of research on large language models, in particular on how to reduce the memory footprint of these large language models. The researchers were able to successfully compress the cache used by the large language models by a bit more than a half, without actually affecting their performance. In addition to tech, there is also a lot of research that relates to machine learning and the sciences. So on the top right, we have an example of how to model animal occurrences and then to predict where they may occur next. And this is like a worldwide model. So for those of you who are interested, please follow the link here to know more. There's also further work on how to use AI to accelerate science, in particular the natural sciences, so for instance, biology, chemistry, physics, or neuroscience. Our research has real-world impact. So every now and then, the UK government runs like an exercise in assessing how good the universities are in their research. This is called the Research Excellence Framework. The last time this has been running was in 2021, and there Edinburgh Informatics was ranked the top in the UK for their impact beyond academia. And this impact includes spin-ups or startups, industry and government collaborations, open source software, and then also impact on policy. Some example impacts are shown here. So research in speech recognition that was done here at the School of Informatics led to startups and spin-outs that are now being used in the UK Parliament to transcribe proceedings. They're also being used by the media company Red Bee Media for subtitling for millions of viewers. Research in neural machine translation has been picked up by companies and has led to tools that is now being used by the UN in more than 192 countries. Research on more the hardware level led to a scanner for bugs in Android, and this led Google to change specs in their Android runtime used by more than 2.5 billion phones. So in addition to our great academic research, we have real-world impact. So by joining Edinburgh, you're joining a place with a long tradition. So Edinburgh has been doing AI for a really long time, namely since 1963. And now world-famous AI researchers have worked in Edinburgh. In fact, for instance, Geoffrey Hinton has done his PhD in AI at the University of Edinburgh in 1978. And his work or his achievements in AI and machine learning awarded him the Nobel Prize in Physics last year. So what is the AI program all about? So before explaining you the structure and the courses of the program, I wanted to show you this photo. This shows actually the view from the classroom or where the students do the practical work, so from the computer room in Edinburgh. So even if you have to do long sessions in the evenings, even if it gets a little bit longer, at least you will be rewarded, not only with interesting work, but also with very beautiful views. Our program essentially is split into 3 parts. So in total, you'll need to have or accumulate a total of 180 credit points. And this is roughly split into 3 parts. So in the first semester, you take 60 credits of taught courses. In the second semester, you can also take 60 credits of taught courses. And then in summer, you do your dissertation, which is also, again, 60 credits. So it's possible to also split the credits non-evenly across the 2 semesters, but we recommend to do it evenly. So it's possible to take 50 credits in semester 1 and then 70 credits in semester 2. Each course has either 10 or 20 credits, depending a little bit how deep it goes, or how long it is, how big it is. And all our courses, we group them into different topics. And the topics are, some of the topics are listed here. So we have the machine learning topic, we have the natural language processing topic. Then we also have courses on vision robotics and autonomous agents. We have courses in bioinformatics, systems and synthetic biology. And then also we have courses in cognitive science and neuroinformatics, courses on databases and data management, and many more. Among the machine learning courses, I've listed here some of the most important ones. So the first course, which is called Applied Machine Learning, that's like a first course in machine learning. So that's for those of you who hadn't taken any machine learning or AI class before. Because as we said, like we are welcoming students from all kinds of different backgrounds. So this would be a course that you would take if you haven't taken any machine learning course before. The next course, Probabilistic Modeling and Reasoning, which will be renamed for next year's to Probabilistic Machine Learning, is kind of like a second course in machine learning. So there we are teaching you how to understand and develop new algorithms from first principles. For those of you with a very good math background, but who haven't done any machine learning before, you could, for instance, take both applied machine learning to get an introduction to machine learning, and then also this course as well, because this course relies a little bit more on math than this one here. So these courses are in the first semester. You can take one of them or both of them, and they prepare you then for further machine learning courses in the next semester, and also for other courses that rely on machine learning. So for instance, we have here a course on advanced topics in machine learning in the second semester, which, as the name says, is an advanced course, and its aim is to introduce you to the newest methods and research. For instance, this year they go into diffusion models and so on. And for instance, these two courses, in particular this one, would prepare you then to take the course here on the advanced topics in machine learning. Another course that is very important is the machine learning practical course. This is a course on deep learning, and this runs over the full year. There you're being taught the practical software packages and tools to do deep learning, and it's also quite project-based as well. In terms of natural language processing, I've listed here also some key courses. So in the first semester, we have again like an introductory course to natural language processing, and also an introductory course to speech processing. And then in the second semester, there is an advanced course in natural language processing that then builds on this course, which again explores current research on natural language processing. In terms of speech processing, in the second semester, there's a course on automated speech recognition and also on speech synthesis. For the topic of vision, robotics, and agents, I've here selected some courses on this topic. So for vision, we have a course on computer graphics in the first semester that provides you with an overview of the state of the art and also gives an introduction to rendering techniques and introduces you to applications. And then in the second semester, there is a computer vision course, which is all about teaching computers how to see, for instance, for object recognition or video classification. For robotics and decision-making, we have here an advanced robotics course in the first semester that teaches the major algorithm techniques and also the practical skills in robotics. And then in the semester, two courses on decision-making, one that looks at decision-making from the perspective of game theory, and one which uses reinforcement learning in order to enable agents to plan and act in complex domains. So this is just a selection of the courses that we have on offer. Here, I have here some clickable links that takes you to places that has the full course list. So please have a look at it offline when we share with you the presentation. So these courses are courses that you will take in the first and the second semester. So after the taught courses, we then have the MSc project phase. Afterwards, that runs mainly from June to August. For the MSc project, you will work with a staff member or sometimes also an industry partner on an individual project that you are designing, essentially. So the way it works is that we first, as faculty, proposes projects, and there will be hundreds of them. But then you're then selecting them, and then later we refine them together so that we have like individualized good match, so that you have a project that you're really enthusiastic about doing. And of course, you can also propose your own project too. So the project is individual work. It can be that you can also meet with a small cluster of other students who have similar topics and who are supervised by the same academic for discussions. But I would like to emphasize this is not a team project, it's an individual project, and importantly, your success in that project will not depend in any way on others. On this page, I've collected some AI-related MSc projects or MSc projects where many of them are AI-related. So we have here, for instance, how to characterize uncertainty neural networks in order to use them for digital twins. We have projects in natural language processing, so it's about neural language models. We also have, for instance, here, how to use AI to forecast wind farm power outputs, or then how to use AI in ICUs, intensive care units. So in order to predict and understand survival rates following discharge from intensive care units. There are also some more abstract projects in there, like the one on, for instance, yeah, which one is more abstract? Yeah, there was one on, like, for instance, the Raman spectrum, which I actually don't know what it is, which shows you actually that by the time you're taking or you're doing the MSc project, you're actually doing stuff that some of the faculty may not be familiar with. So you're really becoming an expert by doing your MSc project. I asked the current cohort of MSc students in the AI program what they think about the program. So they are currently taking courses in the first semester. So their comments are mostly about the courses. So they are not yet in the project phase, and hence the comments are not yet about the project. So as I've said before, and you may have seen, we really offer a huge choice in courses. And that's something that the students really like. So the students here says they really like the breadth of the courses and also the high caliber of the teachers, the good support that you get by the teaching assistants and the demonstrators in the labs. The students say that it is an upgrade from undergraduate, both in content and hardness. So you will have to work harder than in the undergraduate, but I think that's why you're also doing the MSc in order to learn more. So the students really like the freedom to choose the different subjects because you can really choose and combine your courses in whatever way you want. At the beginning of the semester, you're sitting together down with two academics that help you with the course choice. So given the huge choice, sometimes huge choices can be overwhelming, but we are there as academics to help you and support you in your choice. So you're choosing them together. The students also like that we listen to them. So we take their feedback very actively into account. We update the courses in response to the feedback, and we also make it as best as we can relevant to industry as well. And so overall, it's we aim at providing interesting and up-to-date content. I also asked them about the recommendations on how to prepare for the program. And what they're saying here is that, well, this student, for instance, said, like, well, the courses they took used or mentioned probability, calculus, linear algebra as prerequisites. And they had that, but they said, like, yeah, this is really true. The courses, when they mention these prerequisites, they make use of them. And hence they wish they had brushed up on these topics. And also this students is like, yeah, brush up on your maths and be good at program as much as you can before coming. Right. So the reason that they say this is because really the courses require math and probability and programming, and this is reflected in the entry requirements, which I list here on this slide. And please be aware these are the minimal entry requirements. Our program is highly competitive, so these are really minimal entry requirements. So there is a 2.1 honors degree is the minimum requirement in AI, but then also in any of other disciplines, say cognitive sciences, computer science, engineering, even like philosophy, psychology, or mathematics as well. You need to have programmed before, so you will have done or need some experience in one of the key languages, for instance, Python, C, or MATLAB or R, or then also, for instance, Julia, which is a newer language for scientific programming. The current students emphasize the importance of being prepared for math, and we have an entry requirement in terms of math. So you need to have done calculus, linear algebra, probability, some discrete mathematics and mathematical reasoning before. This is really just to help you succeed then in the MSc program. The language that we use for teaching is English, so you will need to be able to demonstrate your English language abilities, and this is just necessary, well, because you have to write a dissertation in English, you want to communicate with your fellow students, which is also quite in English, because we have students from so many countries here, so that this English is just used all the time. Right, so what are the career prospects when you're doing a MSc with us? So our graduates are highly employable, so they go on to companies like Microsoft, Skyscanner, Google DeepMind, or then into the finances, just to name a few. Importantly, you will be extremely well prepared to respond to job adverts like the one here that says what we want from the graduates, or what we want from the potential employee, is that you can decide what approach in data science to use to get the job done. So you decide whether it's cutting edge deep learning, some probabilistic models, or whether actually a simple regression model will do. And our program really allows you to do these kind of things because really we are not only teaching you the state of the art, but also a deep understanding so that you know when to use which method. And I think also we teach you timeless skills that allows you to quickly understand new state of the art, or even create the new state of the art, which is really important in a field that moves as fast as AI or machine learning. So some of you go into industry after their MSc, but some of you may also want to continue their studies and do a PhD, either with us or elsewhere. So I've here listed some opportunities of PhD studies that we here host at the School of Informatics. So we have like PhD positions within the school, and then also we are hosting a number of government-funded centers that focus on more narrowish topics, being in biomedical innovation, natural language processing, machine learning system, quantum informatics, and then also in AI for robotics. And for those of you who are thinking or maybe thinking about PhD studies, so our MSc program is a perfect preparation if you aspire to continue the PhD either with us or elsewhere. This slide here collects some of the key links for the program. So this link here may be the starting point. So this gives you an overview over the degree program. The student handbook here goes more into details. And this link here takes you to a page that lists all the courses. And this link here takes you to a page where you can learn more about funding possibilities.